Okay, 710, work backwards, page 240. We're going to look at this problem a little bit, just kind of talk it out here, how this works. And then we got some we can try on our other side. Working backwards, what does that mean? Generally, what that means is you'll know the end, but trying to figure out where you started. And I created a little example here. So just again, theoretically. You don't need to write this down here. But pretend we're going on a trip somewhere. We're starting here at St. Francis, okay? And what are we doing? We're going to get in the car. We're going to get on Highway 53. We're going to head north, right? Yeah. Up we go. We're going to get to Highway 2, and then we're going to go east. Take a right, okay? And then we're going to get to Math Drive, and we're going to go north, and then somewhere on Math Drive is wherever we're going, okay? We're there. Got it? So now if I said, how are we going to go home, what are we going to do? How do we get home from, what do we got to do? Step by step. What's the first thing we're going to do to go home?
In the car.
Yeah, and then where? What are we going to do?
Go north to Math Drive.
No, we're already there. We're going home. Now let's go back home. Back to St. Francis from here. We're back at Math Drive. Where do we got to go from Math Drive? We got to get to where? Highway 2. So we're on Math Drive. How are we going to get to Highway 2? We're going to go. I went north to get up there. I go north, then I went east, then I went north. Here I am. Here's where I started, right? North on 53, east on 2, north on, there I am. So now I want to get back home. Here I am. What do I got to do first? Go south on Math Drive. Right? So now I've gone south. Now what do I got to do? Go west on Highway 2. And then finally, go south on 53 to get back home. So if I know where I ended, for example, and I said, well, how do I get back to the start? Similar for these problems. How do I do it? In a sense, I'm doing the opposite of every step I took. Most of our problems, they give us a starting point and you figure out the end. But what if they give us the end information and the question is, how much did you have to start with? I have this many cupcakes when I walk out at the end of the day of the bake sale. 4 dozen. But I sold some, I baked some, I traded some, I ate some. How many did I have at the start of the day? So again, you'll work yourself backwards. You won't know that information. So you'll be doing the opposite. So they talk about this problem right here, Mrs. Klein's dress. And it said she used 4 3/4 yards to make a dress. She used 2 3/8 yards for a jacket. Then she bought 1 1/8 more. And then she had 6 1/2 yards left to make 2 pairs of pants, which is totally irrelevant information. But the question is, how much did she have at the end there? So if we wrote this all out step by step, kind of what's going on here, where do we begin? We don't know how much she had at the start. I'll just call it M. You can call it anything you want. But that's how much she had to start with, and that's what we don't know. But what did she do next? She used 4 3/4. So however much she had, she used or subtract from how much she had. 4 3/4 yards, all right, to make a dress. Then she used, so again, we're subtracting forever how much we had in the first place there, 2 3/8 yards in the end. And then it said after buying 1 1/8 more, so that means we're adding 2, we bought more, we bought 1 1/8 more. She ended up, or she had 6 1/2 left, right? We don't know how much she started, that's what it says, but then it said she used, or we subtracted from how much we had, 4 3/4. Then she used, subtract 2 3/8 from a jacket. Then she bought, or add 2, however much we had in the first place, 1 1/8 more. And at the end, she had 6 1/2 yards left. So how could we set this up to solve it? Well, we are going this way with the whole problem now. This is where we end, but we're trying to go back to the start. How are we going to do it? Well, we know how much she ended with there, the 6 1/2, but whatever she bought, we're going to subtract from our total. And then whenever she did use, we're going to add because we're trying to figure out how much she has. So stuff that she used is how much she had in the first place. Stuff that she bought or that we're subtracting because she did not have that at this point. She didn't have it at the start. She bought it later on. So we're going to add the 2 3/8 and we're going to add the 4 3/4 together here. And again, I'm not going to, I'll spare us the time. I mean, common denominator, we can look for what we can here, but put it all together, 6 1/2 minus 1 1/8 plus 2 3/8 plus 4 3/4 would give me a grand total. It says it in the book. You can see all the math right there, step by step. We're just speeding this up, but 12.5 yards when I solve this right here. This is what I'm going to get. And that should make sense. I could go back and test it. Okay, now I know she had 12.5 yards. She used this much. She used that much. She bought a little more. That's how much she has left. And again, I will spare us testing the whole thing out here, but just think it through here, like how it worked. How much did she have? How much did she use? How much did she buy? How much did she end with? Well, now we're going the other way. We don't know this here. So anything that she uses, we're going to add because they were essentially putting it back, right? Put it, unspooling it or whatever you want. We're going all the way back to the beginning here. So we're adding the stuff that we used back in. We're doing the opposite order of operation to solve this problem. And again, you can kind of think about this example where you go through, it's just to get back home, you take the exact opposite route you took to get there. What was once north now becomes south. Which was once go to the right now becomes go to the left to get back home, right? Do the opposite, do the opposite. So let's look at number 1.
Okay.
All right. It says, after losing 2.5 pounds in each of the first 2 weeks of March and gaining 1 3/8 pounds in each of the next 2 weeks, Ted's prize-winning piglet weighed 110 pounds. How much does piglet weigh on March 1st? And again, they kind of walk through it a little bit here, so we'll save our rating for number 2 for the most part here, but let's just think it through here. What are they asking me? Well, they want to know how much the pig ended at the start of the month. Do we know how much it ended at the end of the month? Yeah. So pretend the pig weighed 10 pounds at the end, and I'm just going to rewrite it with simpler number. I'm going to say lost 2 pounds each of the first 2 weeks, okay? And then we'll say it gained 1 the last 2, okay? 1 pound. So I'm just using simpler numbers here, last 2 weeks. And then we'll say it weighs 10 pounds at the end. So how much did it weigh at the start? And we can think this through here. So however much it weighed at the start, 2 pounds for 2 weeks. You can combine these if you want, but it lost 4 pounds. Agreed?
Yeah.
And then it gained 1 pound for each of the last 2 weeks, so it gained 2 pounds total, right? You could certainly write it out this way, -2 plus 1, or you can just combine them, I mean each week here. But then at the end, it weighed 10 pounds. So if I go backwards here, this is where I ended, what would be my next 2 steps here, working back? Because the gain pounds are going to be lost and the lost pounds. Right, if I add 4 or subtract 2, I'm going to do the opposite. How much did the pig weigh at the start? How much did the pig weigh at the start of the month? On March 1st? 12 pounds. And if we test it, weighed 12 pounds, so it lost 2 pounds first week, now it's 10 pounds. Lost 2 pounds the next week, now it's 8 pounds. Gained 1 pound, or lost 2 pounds the first, 12 pounds. Lost 2 pounds, now it weighs 10 pounds. Lost 2 more, now it weighs 8 pounds. Gained 1 the third week, now it weighs 9 pounds. Gained 1 the fourth week, there's my ending. Back to 10 pounds I go. So again, I did the opposite. What once was a gain now becomes a loss. Once was once a loss now becomes a gain. Because again, I know the end, trying to work the other direction with the problem.
I get it.
All right, well, why don't we try number 2?
Oh.
See how that works. It's just the same thing. It's just you combine and add.
Well, what
Well,
was the answer? See if I know.
the answer is 112 1/4. And again, to solve it there, I would subtract 2 3/4 and add 5. Add 5, subtract 2 3/4.
Are these gonna be on tests?
Oh, yeah. I actually did get
These are more extra credit, but again, you guys, I mean, if you can get your mind, I mean, this can really help for down the road here. I mean, will we explicitly do a ton of these problems this year? We will not. Will you see them on standardized tests, MAPS tests, high school type questions? Very much so. So, can you guys handle this lesson? I think so.
Oh, yeah.
If I didn't think you could, we just not do it. I think you can handle it. So, number 2. Let's see what you guys can do with this. So at the end of the school day, Miss Dinger had 17 crayons left. Okay? So how many is she ending the day with? So throughout the day, she remembered giving out 14 crayons in the morning, getting back 12 at recess, giving out 11 more at lunch. So how many did she have at the beginning of the day?
I have the answer.
At the end of the day, she has 17 crayons. And then somewhere along the way, she gave out 14 in the morning. 12 of those came back. 11 more went out. How many did she have at the start of the day? And again, I can write out an equation, but how I solve it, I'm going to ultimately do the opposite. If I write out the equation, exactly what's represented here, at the start of the day, I have no idea how many crayons she has. That's what I'm figuring out. That's my variable in my equation. But she gave out 14, subtract that from the total. However many she had, she gave out 14. 12 of them came back. And then 11 more went out, and then at the end of the day, she had 11 crayons left. So then if we just start working backwards, getting all the way back, our subtracts become adds. So I can set it up here right at the end if I want. She had 17, well, I'll just go this way. She had 11 at the end. So she gave out 11, so back she got those back before earlier in the day. And then the 12, and then add the 14 back in. I did the exact opposite of every single step
Oh,
here.
I didn't add the 11 that she had at the end of the day.
Because now I essentially rewrote the equation this way. I rewrote the equation this way. I'm still solving for something, but now I'm solving for the start of the day. Start of day. So 11 plus 11, 22, minus 12 is 10, plus 14 is, why do they have 30? What do they do? Oh, where did I forget where's my 17?
School day, she had 17.
Right. So 17 left. I should go this way with it here. I wrote the wrong, which number did I write wrong? I wrote 11 twice.
11, yeah.
Right, my bad. There we go. So where we did, and then, right, 17. Sorry about that. That's my problem there. So how many I ended with? Add back the 11, 28. The 12 I got back, subtract them, 16. Add the 14. She had 30 crayons at the start of the day. She had 30 crayons. And again, now it's easy. So we know the answer is 17. Plug it back in. 30. She gave out 14. Now she has 16 left. And then she got 12 back, so now she has 28 crayons. And then she gave out 11 more, 28 minus 11, 17 crayons. Guess nobody turned them in after lunch. 0 returned after lunch. 11 given out, 0 returned. Right. And again, it's just all my adds have become subtracts because I'm going the other direction. Essentially, I'm switching all my orders of operation around in the problem. This is how it is algebraically. And again, you guys, we don't have the skills to see how I can solve this algebraically at the moment here. Next year you will. And we will solve this a little differently. But try number 3.
Okay.
Jason was given his allowance on Sunday. On Monday, he bought a book for $2.95. On Tuesday, Kurt paid Jason the $3.50 he owed him. Jason now has $6.05. How much was his allowance? And again, you could think it through. He spent some money and he was given some money.
I don't even get. I've never got paid for that. But I'm getting paid to paint my chicken. Yeah, that's like
All right. Total voluntary basis, if you want to contribute a guess to the final answer.
$5.50.
$5.50. Anybody else?
I got 550.
Yep, that's fine. So I wrote out at least the equation of where everything starts because we don't know how, that's where it all began. We have no idea. Guys, shh. And again, this is not how I'm going to solve it, but this is understanding where you start and then being able to work backwards. If you can get this on paper, that's very helpful because we have no idea how much money he started with, his allowance. That's, well, but whatever much he had, he spent $2.95 on a book. We're subtracting that from his total. And then Kurt gave him that $3.50. We're adding that to his total. All said and done, $6.05. So to solve it, again, I'm going to work all the way backwards. What was once adding is now subtracting $3.50. What was once subtracting $2.95 becomes adding $2.95.
The only way you get this is like writing it the right way.
Right.
I just subtracted 295 from 350.
And again, the truth be told, there's more efficient strategies to solve this type of problem using algebra, which is, you guys don't have that yet. Sorry. I don't know what to tell you. But then, yeah, solve it all out there. 605 minus 350 is $2.55. $2.55 plus $2.95. Correct answer is $5.50. So that's how much he started with. That's a weird allowance, but you know, $5.50. All right, try number 4.
So I got it.
This will probably be the last one here. So,
Yay!
homework 1 through 8.
Oh, that's not even there.
I know.
That's how much I get paid for
Yeah.
flushing my toilet.
None of them are ridiculously long.
Okay, that's
Um,
not.
in the homework, 1, 3, and 4 have a little bit of, but not real, like fourths and halves and stuff for your fractions. So
It's $10 for setting that.
all of them will require multiple order of operation skills to solve, more than one thing to undo. But try number 4. And again, these are kind of fun here. Well, to me, but. So Lee wrote a 2-digit number. I have no idea what that number is, but whatever that number was, she divided it by 9, then added 24, then doubled the result, and then got an answer of 64.
What?
So what number did she write?
Add a
She wrote a 2-digit number, and then what did she do with it? She divided it by 9 first, she added 24 second,
Okay.
she doubled the result third. And remember, the order matters, just like the driving directions. I can't, first I had to go south on Math Drive, second I had to go west in that order. So I need to undo things to get home the same way in the exact same order, well, reverse order. So whatever I did last, I need to undo first, if that makes sense.
Ow.
Oh, was it 2-digit number? I didn't know. Oh my god.
Oh, I did it. Oh, yeah. Okay, I think I know the answer.
Number 5 could be fun, but as you could probably guess, that's going to take some time to
Yeah.
mathematically
I don't
solve.
think I got number 4 right.
So first, I'm just going to write up where we are, and then we'll look at how we should actually solve it. So I have no idea what that 2-digit number is. I'm just going to call that n because I don't know what it is. That's what I'm trying to figure out. But whatever it was, what did she do first? Well, she divided it by 9. And then that answer, next, she added 24 to it. And then finally, she doubled it. And ultimately got a final answer of 64. Right? So now it's just going backwards. So what's the opposite? So now I got 64. I'm not multiplying by 2. I'm dividing by 2. So now I'm at 32. And then before that, add 24. So I should subtract 24. Now I'm at 8. And not divide 9. I'm going to by 9. And I get, there's my starting spot.
Oh, I got it.
70, and again, you could plug it back in. 72 divided by 9 is 8. 8 plus 4 is 32. 32 times 2 is 64.
I got it. Let's go.
We just, again, it can help to write out where you start and then just peel your way backwards, step by step, doing the opposite order of operation. So again, having the equation can be very helpful, especially with this type of problem, because I have to do these 3 steps in that exact sequence. If I don't do them, if I decide I want to subtract 24 first or something, I'm going to get a whole different answer. And again, it's just like the driving directions. Again, to get home, first I got to go south on this road. Then I go on this road, then this road. I can't say from here I'm going to go south on 53 and then south on Math Drive and then west on. That wouldn't make any sense. Those roads, it's not even possible, right? I mean, think about it. So to get back, you have to take the same steps in the same order that you did them here. All right. We were able to kind of move it a little faster through some of the other ones because we were only adding or subtracting. But this one, since we're doing 3, we got to divide, multiply, subtract. I mean, if we don't do them in that first, what did I do, and then that order there, you're not going to get the right answer. So the order matters. Make sense?
Yeah.
Okay. So again, do the best you can. Again, it's not meant to crush you on the homework. How about this? If you guys only have to do 5 of the 8. If you want to do more, that's fine. Maybe
5
I'll
and 8.
float you a little extra credit or something for the homework. There's 8 problems. At the minimum, do 5 of them. Okay. If some are too hard, just okay. I don't want you to spend time. How about this? Just do 4. 4 is the requirement. If you do all 8 and show your work well, I'll give you some extra credit. I'll give you a point. Yes. If you do all 8 and show your work good, doesn't matter, then yeah, I'll give you a point of extra credit. But homework requirements, if you just want to get this done, you need to do any 4. Clear? Make sense? Yes? Right. Do 4. If you want the extra credit, do all 8.